Good day. This is Group 11 and we are here today to discuss our topic, the Natural Language Processing or NLP algorithm. So, human beings are the most advanced species on Earth. And there's no doubt in that, and our success as human beings is because of our ability to communicate and share information. Now that's where the concept of developing comes in, and when we talk about the human language, it is one of the diverse and complex part of us, considering a total of 6,500 languages that exists, so coming to the 21st century, according to the industry estimates, only 21% of the available is present in the structure form data is generated. As I speak, tweet and send messages on WhatsApp or the various of the crops of Facebook, and majority of the state exists the textual form. Now, in order to produce significant and actionable insights from this data, it is important to get acquainted with the techniques of text analysis and natural language processing. So let's understand what is text mining and natural language processing. So, text mining or text analytics is the process of deriving meaningful from natural language text. It usually involves the process of structuring the input text, deriving patterns within the structured data, and finally evaluating and interpreting the output. On the other hand, natural language processing refers to the artificial intelligence method of communicating with an intelligent system using the natural language, as text mining refers to the process of deriving high-quality information from the text. The overall goal is here to essentially turn the text in data analysis via the application of natural language processing. Satisfied text mining and NLP go hand in hand. So, let's understand some of the application of text mining or natural language processing. So, one of the first and important applications natural language processing is sentiment analysis, be it Twitter sentimental or the Facebook sentiment as it's being used heavily. Now, we have the implementation of ChatPod. Now you might have used the customer chat services pride various companies, and the process behind all of that is because of the NLP. Now we have speech recognition. And here we are also talking about divorce assistants like Safari, Google Assistant, and Cortana, and the process behind all of this is because of the natural language processing. No. Machine translation is also another case of natural language processing. And the most common example for it is the Google Translate, which uses NLP to translate data from one language to another, and that too in the real time. Now, other application of an NLP includes spell checking, keyword search, and also extracting information from any doc or any website. And finally, one of the coolest of natural language processing is advertisement matching, basically recommendation of ads based on your history. Now, NLP is divided into two major components. That is the natural language understanding and the natural language generation. The understanding generally refers to mapping the given input into natural language into useful representation and analyzing those aspects of the language, whereas generation is the process of producing meaningful phrases and sentences in the form from some internal presentation. Now, the natural language understanding is usually harder than the natural language generation because it takes a lot of time and a lot of things to usually understand, particularly especially if you are not a human being. Now, there are various steps involved in the natural language processing, which are tokenization, stemming, lemmatization, the POS tags, named entity recognition, and chunking. Now, starting with tokenization. Tokenization is the process operating string into tokens, which in turn are small structures or units that can be used for tokenization. So, if we have a look at the example here, taking this sentence into consideration, it can be divided into 7 tokens. Now, this is very useful in the natural processing part. Now, Coming to the second process in natural language processing is stemming. Now, stemming usually refers to normalizing the words into its base or the root. So, if we look at the words here, we have affectations, affects, affections, affected, affection, and effective. Now all of these words originate from single root word, and as you might guessed, it is effect. Now, stemming algorithm words by cutting off the end or the beginning of the word, taking into account a list of common prefixes, suffixes, that can be found in inflected words. This indiscriminate cutting can be successful in some occasions but not always. So, let's understand the concept of limitation. Now, limitation, the other hand, takes into consideration the morphological analysis of the void. To do it is necessary to have a detailed dictionary, which the algorithm can look through to link the from back to this original word or the root, which is also known as lemma. Now, what lemmatization does is groups together different inflected forms of the word called lemma and is somehow similar to stemming, as it maps several words into one common root, but the major difference between stemming and limitation is that the output of the lemmatization is a proper word. For example, a lemmatizer should map gone, going, and went into go. That will not to be the output for stemming. Now, once we have the tokens and once we have divided the tokens into its root form, next comes the POS tags. Now, generally speaking, the grammatical type of the word is referred to as POS tags, or the pots of speech. Be it the verb, noun, adjective, adverb, article, and many more, it indicates how a word functions in meaning as well as grammatically within the sentence. A word can have more than one of speech based on the context in which it is used. For example, let's take the sentence, who is something on the internet. Here, Google is used as a verb, although it's a proper noun. Now, these are some of the limitations, or I should say the problems, that occur while processing the natural language. Now, to overcome all of these challenges, we have the named entity recognition, also known as NER. So it is the process of detecting the named entities such as the person name, the company names. We have the quantities or location. Now it has 3 steps, which are the noun phrase, identification, the phrase classification, and entity disambiguation. Google's CEO Sundar Pichai introduced the new Pixel 3 at New York Central Mall. So if you can see here, Google is identified as an organization. So in the picture as a person, we have New York as Lucky, and Central Mall is also defined an organization. Now have divided the sentences into tokens, done the stemming. The lemmatization added the tags as the named entity recognition. It's time for us to group it back together and make sense out of it. So for that we have chunking. So chunking basically means picking up individual piece of information and grouping them together into the bigger pieces. Now these pieces are also known as chunks. In the context of NLP, chunking means grouping of words or tokens into chunks. So as you can see here, we have pink as an adjective, panther as a noun, and D as a determiner. And all of these are together chunked into a noun phrase. Now this helps in getting insights and meaningful information from the given text. Now you might wondering, where does one execute or run all of these programs and all of this functions on a given text file? So for that, Python came up with an LDK. Now what is an LDK? Again, an LTK is the Natural Language Toolkit library, which is heavily used for all the natural language processing and the text analysis. Example of natural language processing, NLP. Imagine you're using a virtual assistant, like Amazon's Alexa, which relies heavily on NLP. You say, "Hello Alexa, what's weather like today?" Speech recognition, or NLP input. The virtual assistant uses NLP to recognize and transcribe your spoken words into text, converting your voice command into a format it can understand. Now, We have natural language understanding comes into play as the system analyzes the text. To comprehend the intent behind your query, it identifies that you're asking about the weather. Next, query processing. The system processes your request, considering factors like location, time, and date. It understands that you want current weather information for your specific location. Now, we have information retrieval. The virtual assistant uses NLP to access a weather database or service, extracting relevant information about the current weather conditions for your location. Natural language generation, or NLG. Finally, the virtual assistant converts the retrieved information into a natural language response. This seamless interaction involves multiple NLP components, from understanding spoken language and interpreting intent to retrieving information and presenting it in a way that feels natural to the user. Virtual assistants exemplify how NLP enhances human-computer interaction, making it more intuitive and user-friendly in various applications. Thanks for watching.